Hello class, welcome to Case Study 2A Notes Part 5, where we're going to look at a complete hypothesis test for Case Study 2A. Okay, this is going to be the last video. I'm going to try to keep it short. Going to go through one example of a hypothesis test from start to finish. We also have our Case Study 2A that we've completed as an example from start to finish. And then I also have two examples after this, 12 and 13, that you can also practice going through. Okay, so for this problem, according to the document Consumer Expenditures, a publication of the Bureau of Labor Statistics, the average consumer unit spent $18.74 on apparel and services in 2006. That same year, 25 consumer units in the Northeast, that sounds like our sample, okay, had the following expenditure in dollars on apparel and services. And so here it gives us a list of data. Okay, at the 5% significance level, do the data provide sufficient evidence to conclude that the 2006 mean annual expenditure on apparel and services for consumer units in the Northeast differed from the national mean of 1874? Assume the histogram is bell-shaped. Okay, assuming the histogram is bell-shaped, that's what lets us know we have an approximately normal distribution, which is going to help us to answer this question. Okay, first we need to answer that question, then we need to find an appropriate confidence interval for the 2006 mean annual expenditure on apparel and services for all consumer units in the Northeast. Okay, so note the sample mean and standard deviation of the data are 2060, 76, and 350 and 90 respectively. Okay, so I'm going to go through all the steps of hypothesis, starting with the first 5 ingredients. Okay, so our population here, and I have a little edit I want to do to our population. Okay, our population is going to be all consumer units in 2006. Okay, because when you come up to the top here, where we get our information about the whole population is from the publication of the Bureau of Labor Statistics. The average consumer unit spent $18.74 on apparel and services in 2006. Okay. The sample is going to be what we have underlined in blue here. Okay, the 25 consumer units in the Northeast, again, in 2006. We want to go ahead and specify the year. All right, the variable of interest is going to be, well, what did I measure on those 25 consumer units? Okay, and if you finish reading the sentence, the 25 consumer units in the Northeast had the following annual expenditures in dollars on apparel and services. So the variable of interest, annual expenditures on apparel and services in dollars. Okay, now the next step is going to be parameter, and I'm always going to ask, what's the symbol for our parameter here? Okay, this problem has been talking about averages. You got that word average and mean floating around. Okay, so our symbol is going to be mu. All right, it's going to be the mean annual expenditure on apparel and services for all of my consumer units in 2006. Okay, number 5, statistic. Okay, what's going to be the symbol for our statistic? Since we're talking about averages, yes, it's going to be X bar. And when I say my X bar in words, I want to incorporate the words from my sample and the words from my variable of interest. So X bar is going to be the mean expenditure on apparel and services for the 25 consumer units in the Northeast in 2006. Okay, and then we have the value of the statistic. That's going to be 2060.76. That number came from this last sentence right here. Okay, this was our X bar, and that's going to be our S. All right, so the value of statistics is 2060.76. The next thing we need to do is set up the null and alternative hypothesis. I'm going to go up here and kind of point out where it is that I saw the null and alternative hypothesis. Okay, so at the 5% significance level, do the data provide sufficient evidence to conclude that The 2006 mean annual expenditure on apparel and service for consumer units in the Northeast differed from the national mean of 1874. Okay, so that means our HO mu equals 1874, and HA is going to be mu does not equal 1874. Okay, so that word differed or different from or not equal to, those are all synonyms that I could have used in place of that word differed to let us know that what we have, oops, went a little too far, that what we have going on in our HA is a do not equal to sign. Okay, the next step is to give the test statistic, and I want to make sure you write the formula, show me your values plugged in, and box the final value of your test statistic. Okay, so I'm gonna scroll back up to the top, give you a chance to pull out any necessary information. Okay, maybe take a moment, pause here, and I want you to practice calculating your test statistic. Okay. And so what we have for the value of our test statistic, I got 2.66. Okay, again, we want to make sure that when we're plugging this into our calculator, we're doing brackets or parentheses around the top and the bottom. Okay, and you should get 2.66 as your test statistic. Okay, the next thing we need is to give the null distribution. So since this was an assumed normal population, okay, we were able to calculate T, and that means we have a student's T distribution, okay? And the T distribution is dependent on degrees of freedom, okay? Degrees of freedom is n minus 1. So our sample size is 25. That means degrees of freedom is going to be 24. Okay, so our distribution, our test statistic T follows a T distribution with 24 degrees of freedom. Okay, since I have some space, I'm gonna go ahead and just draw what that looks like right here. And we're over here at 2.66, and we're also going to be concerned down here with negative 2.66. And this is our T24. That's what our distribution looks like. Okay, so the next step after the null distribution is calculating a p-value. All right, so the first thing we want to do is we want to actually write our probability statement. And since this is a two-tailed test, it needs to start with 2 times the probability, okay? So 2 times the probability of observing the value of our statistic from our sample, okay? Or more extreme if HO is true. So 2 times the probability that T is going to be greater than or equal to 2.66. Not sure why I carried the 1 over here. Not too important at that far back in the decimal. Okay. So if I come back here in pink again, here's my probability statement. Okay. And this shaded area up above in pink is what represents that probability statement for us. Okay, so the chart only gives us right-tailed probabilities. So when we go to the chart, we're gonna look up what that shaded pink area is telling us, and then we're gonna double it. Okay, so we're gonna go to T24, okay, 24 degrees of freedom. Oh, let's zoom out a little. So here we are at 24 degrees of freedom, and we're looking for the number 2.66. .66 looks like it's going to fall right between these two numbers. So we go up to the top, and we see that, hey, the probability that we want is going to be between 0.005 and 0.01. So the single-tailed probability is between 0.005 and 0.01, but we want to double this. we're gonna double all of that to give us 0.01 is less than 2 times my probability statement, which is less than 0.02, okay? So again, gonna emphasize what I have boxed in pink. Those are exactly the same statements, okay? And the reason it's exactly the same is because we've already defined what our p-value actually is up at the top. Okay, so we get our p-value of between 0.01 and 0.02. Okay, so I believe this question said to use a significance level of, let's just go double check. At the 5% significance level. Okay. So is this p-value smaller or bigger than 5%? Well, 5% would be over there to the right. So the p-value is low. What do we do when the p-value is low? We reject HO and accept HA. Okay, and I'm gonna scroll back up a little bit because we haven't written out a conclusion in a while. So what are we gonna do? We reject HO and we accept HA. Okay, and so our mu we defined up here. Okay, so to say HA in words, the mean annual expenditure on apparel and service for all consumer units in 2006 is different from 1874. Okay, and 1874 represented the national mean. So we do have evidence of a difference here. So we have sufficient evidence that the mean annual expenditure on apparel and services for all consumer units in 2006 differs from the national mean of 1874. Okay, so we have our decision here and our conclusion on the next line. Okay, so the next thing this problem asks us to do is calculate a confidence interval. Okay, and so a little reminder here, since our alpha right here, alpha was set at 0.05. So what confidence level are we going to want? That means we're going to want a 95% confidence interval. Okay. So we want to start with our confidence interval formula, x bar plus or minus some value from the t-table times s divided by the square root of n. Okay, how we get that value from the t-table is going to be derived from this 95%. Okay, so I'm going to zoom in right here. So we put 95% in the middle. And then we have to figure out, well, what belongs in the tails? And if we do 1 minus 0.95 divided by 2, we're going to get 0.025. And that's the number that belongs in my tail area. Okay, and this negative t and this positive t, that's what we want to solve for. Okay, so now what we're going to do is we still have the same degrees of freedom we were working with before, and we want to look for this area of 0.025. So when I go to my z table, we kind of got a lot going on here. Okay, so I still have my 24 degrees of freedom lined up here at the bottom, okay? And now what I'm gonna do is I'm gonna go across the top and I'm looking for 0.025. And I find it right here. So that means if I go all the way down, 2.0639, that's the t value I wanna use in my confidence interval formula. So my t-table value is 2.0639, okay? X bar, S, and N you get from the problem. Go back up to the very top and pick out those numbers. Okay, take a moment, pause right here. Go ahead, complete this formula, get your confidence interval, and write a statement about it. All right. So your final confidence interval should be 1,915.92 to 2,205.60. Okay, so you don't have to show this step here if you don't want to. Okay, but keep in mind this, all of this in this purple box, multiply, divided, is what gets me that 144.84. Okay, 144.84, that's going to be the margin of error in our problem here. Okay, and so what does that mean? That means we are 95% confident that the mean annual expenditure on apparel and services for all consumer units is between the lower bound and the upper bound. Okay. You just want to put your parameter in words whenever you're talking about what you're percent confident of. Okay, it's always the parameter. Confidence intervals give us a reasonable range of guesses for our parameter. Okay, and anytime you do confidence intervals with hypothesis testing, your decision, what you write in your decision of your hypothesis test, should coincide with what you write for your interpretation of your confidence interval. Okay, so looking at the top of the page, we had evidence that mu was different from 1874. And then we got a confidence interval that was different than 1874. Do you agree that the number 1874 does not fall in this interval? It does not. So that confidence interval is different from 1874. The conclusion of our hypothesis test is that mu is different from 1874. So what we have written in our conclusion up here does support the decision or the interpretation of our confidence interval that we also had. Okay, well, thank you for tuning in for the last video of the week. This is the completion of case study 2A notes. So whenever I post videos next Monday, they are going to be over case study 2B. So make sure to get some practice in, make sure you look at the homework before you move on to looking at the case study 2B notes. Okay, thank you guys. You have a great day.